Okay, so let's get started though. Alright, so today we're gonna go over project 2 in a little more depth for what you have to do. Then we're gonna finish up our example that we were doing last class that that I kind of blanked out on. And then we're gonna go over how to make a heat map and then how to make a scatter plot with some text labels that are kind of automated. Alright, so the deliverables for project 2, they're up now. And I guess they're up now, so you can check it for you can check them by going to files. I still need to make an assignment page for this, but you can click on files and then you can go to project 2 and then you can look at the deliverables right here, and then I have all of the different spreadsheets that we need for this project. Okay, so let's take a look at this. So this is mostly the same as project 1. There's a few differences. I do like that. Alright, so one of the differences, we have some different spreadsheets. So we have the county population spreadsheet, so we still have that. And then we still have the vaccination spreadsheet, so how many vaccines were given. But we also have two new ones. So we have some case data, so if there's a positive test or not. And then we also have vaccine shipment and delivery. Oh yeah, I just thought of this right now. So, for project 1, when I talked about the figures that you have to make, I also gave you the column in the spreadsheet that you needed. I forgot to do that this time, so let me put a note. So I'm going to indicate that again this time, so I'll update this probably later today. You can definitely still get started. You should be able to tell which column you need, but just to avoid confusion, I'm going to specify which column of which spreadsheet. Okay, so this is due on May 22nd, so that's after finals. I have it after finals. It's that Saturday, just so you can finish the finals, and if you have some more things that you need to finish up on the project, you can do it then. Alright, then the data that you need to include for the project, that's going to be for May 18th. So I'm going to upload that data then. Actually, I'm going to upload it on May 19th because I have to wait a full day for that to come. But I think May 19th, that's the Wednesday of finals. So
Wait,
that's
really
it for
quick.
this class.
The first two, we already have those data sheets, right?
Yeah. You have them. Yeah.
We don't have to do anything when you upload the new spreadsheets, right? We just have to like it's gonna update automatically if we did it right.
Yeah, correct. Yeah. And yeah, that's kind of the point, right? I know I didn't read through all of your comments yet for that past quiz for what was your favorite thing of the project and least favorite, but I saw there's one, and I'm sure there's a few for that you didn't like that I updated the spreadsheet because then you had to change some stuff in your code. But that's part of the point for why I'm doing this, because if you wrote your code correctly, you don't have to change anything at all. And that's how you should try to, write your code. Okay, so let's see. There's nothing new in here. Basically all the same stuff. We're going to be using Discord. You're going to be Googling how to do some stuff, probably some like small things that I may have not covered in class. There's no way that I can go over every little thing, and especially because there's different ways to go about solving stuff too. But of course, if you have a question, I can answer, but the first thing that you do is hopefully you can look it up, because I can't answer a million small questions. I mean, I try to, but it takes time. Okay, report structure, this is going to be basically the same as project 1. So write-ups, like I thought, that was probably like the main thing that you guys didn't like for the first project, which I get. I wouldn't like it too, but one, it's a way for me to check that you know what you're writing it for your code. And it's also like almost an anti-cheat method, because if you just copy and paste someone else's code, well then, and if I didn't have you have a write-up, you would maybe get away with it. It would still be obvious to me if you copy and pasted someone's code though, because everyone has little kind of differences. But still, it's like an anti-cheat method too, because if you copy and paste someone's code, you still need to explain what it means. But this time around, you don't need a write-up for essentially the entire code like project 1. So we're going to do it like this. So there's still going to be 2 sections for your write-up. The first one is for your data reduction, but it's just going to be all of the code needed to make these figures, and you can see the figures in the next section here. So it's figures A.1 and then figures B.1 through B.6. Now, that it is almost all of these figures, but this figure here for B.7 and this figure here for C.1, they both require their own data processing section. So all of this here for A.1 to B.6, all of that can be done or calculated in one for loop. So that's basically just going to be one pretty big loop. Okay, so you're going to do that, and then also, just to be a little more specific for what this means this time around, that means that you need a write-up for when you import your data. So you can just do this for the block of code, because we're going to be importing 4 spreadsheets. But so you can just say, we're using the read table function to import these different spreadsheets. But if you're also sorting the table here, so you can do that too. When you use the read table function, you could say t or whatever variable equals sort rows, and then read table, and then you can specify how you want to sort that table on the same line. So basically, if you have any little small differences, just make sure that you mention that. Alright, so any prep work done. So what I mean by that is stuff like if you convert the class type here. So we do that occasionally, like if we convert a cell array to a string array for some column in our table. I want to talk about that. Have a write-up for when you define reference variables that you define so you can avoid hard coding. So for this project, that would be like if we had a variable called amount or something like that, which would be for when we make our per million plots. We could, instead of saying multiplied times 1 million when we do that equation that we talked about, you can just say multiplied by amount. So if we want to dynamically change all of our plots to instead of per million, it could be like per 100,000 or something like that. So basically, if you define a reference variable, make sure you have a write-up on that. And then anything else. So, maybe you also did some more prep work, right? Next thing, initializing arrays. So you can say this, you can have a write-up just for the entire block of code. So you might be defining or pre-allocating the size for many arrays that you're going to be using in your for loop. So you could just say, here we're pre-allocating the size of all of our arrays to make our code more efficient, so the array size doesn't continually change inside of the for loop. Okay, next one is your actual for looping section of the project. So you're going to be using for loops, right? That's the main point of this project. So you're going to have to talk about every single line of code in your for loop, and really that's when you're calculating stuff. Okay, and then any other code that you had to do before you were able to start plotting. Okay, and then the second part of the write-up is when you actually talk about the plotting code specifically. So again, we're going to be doing this for 2 different figures. So one of them is for B.2, which again you can see down here. So that's going to be a heat map figure. And then figure C.1, that's a scatter plot. So this may look like it's more than the first project. It's not. I just gave more detail this time around. So it shouldn't be as long of a write-up. Okay, so these are all of the figures. It's more figures this time, but some of these figures, it's, you have all of the data and we're just making a few figures from that specific data. So first one is a bar chart. I'm going to actually pull up the figures side by side. So first one, we have this bar chart here. So this is the percentage of the population that's fully vaccinated up to the most recent date, sorted by the top 15 counties that are most vaccinated per that most recent date.
Does it have to be alphabetical like it says there?
This isn't even alphabetical. It's if it is, yes, see, there's Contra Costa over here. This is sorted by the most vaccinated for the recent date.
Oh, that's the heat map. Okay.
Oh, yeah. Yeah, so some of the heat maps, one of them is going to be sorted alphabetically, and one of them is going to be sorted by the most vaccinated. Okay, so we have this bar chart. Next one, we have all of our heat maps now. So the first one is the percentage of population fully vaccinated over time up to the most recent date, and so this one is sorted alphabetically. And also, last time when I showed you this figure, it was day by day. That gets way too like chaotic, especially once we continue to add like a whole nother month. It's going to be really hard to look at each day, especially the date. So here, this is week by week, and I think I noted this somewhere. Maybe it's later on. But this is week by week, so maybe I'll add this also here, be a little more specific. Make another note. Figures week by week. Alright, so this is week by week. Again, just to make it not as like smushed together for the dates. Okay, next one is the percent of population vaccinated over time up to the latest date, but this time it's sorted by the top 15 most vaccinated counties for the most recent date. So this is basically that last graph we just saw, but it's sorted by the top 15 most vaccinated counties for the most recent date. And basically a lot of these counties are really small, so it's probably easier to vaccinate them. But then you see like San Francisco. They're doing pretty damn well. Next one, percentage of cumulative doses given. So this is for the total amount of doses given up to or for the most recent date. And this is sorted, this is just alphabetical. And this is for each of our 3 different manufacturers that we have here. Okay, so basically you can see, J&J, there's like, even before the pause, there's hardly any of them. And then Pfizer and Moderna. And it's kind of interesting that some counties, they have like a really large amount of using like Moderna versus Pfizer. And actually this one, it's interesting. If you make this heat map and you have the labels by default, the numbers will be on the cells. This will say that it's 120%, and that's not an error. At first I was confused, like, what? Like, I thought it was an error, but it's not. Yeah, Lissandra, I'm not going to pull up the code. Okay, so it's not an error. I think basically people that didn't live in Alpine, they went to Alpine to get the shot. Because there was like, I think 600. No, maybe there's more. I don't know, there's some amount of Moderna doses given, and that was more than the amount of people that lived there. So just be aware, like, if something like that happens, kind of think through it. Okay, next one is so this is when I mentioned that basically you have all of the data and we're making a few like extra plots. So from the past plots that you looked at, we already have, all of this data stored somewhere. But we're also making a few more plots here. So this is the cumulative percentage of Pfizer doses given for the most recent date by counties, sorted alphabetically. So here again, you can see that some counties use or have distributed quite a lot of Pfizer doses compared to the other manufacturers. And we did it for Moderna. And then Johnson & Johnson, it's like almost a fully purple screen here because there's been so little distribution for that. Okay, we're almost done now. So this one here is the percentage of doses administered for the doses distributed. So basically, that's for the percentage, how much did each state use or actually administer for their doses for what they received. So basically, are they using all of the doses that they received or not? And I think this is kind of a cool graph too. You can see some states not really administering too much even now, like Alabama. They're not using all of them. And you can see that there's also some like territories, so that's included for the data set. So like Northern Marina Islands, and there's like, I think Guam is in here, so stuff like that. Yeah, there's Guam. Yeah, I don't know, like hopefully they eventually actually administer them and don't waste them, because, well, that would kind of suck.
It's probably like a huge anti-vax state or whatever.
Yeah, see, I wasn't trying to say that, but it could be.
You know, it's true though.
Yeah, for some
It's
it
natural
probably is the
selection.
case. Oh my gosh. Okay. And then the last one is this scatter chart, which I also think this is a really interesting chart, personally. So this is the COVID-19 cases versus the percent of population that's fully vaccinated. So this data range is, maybe I should make this title a bit better. So the total amount of COVID cases, this is per million of the population. And this is from February 1st, so that might seem like a random date. That's the most, that's the furthest back date, whatever, for that this spreadsheet has. So that gives us the total, or the number of cases per million of a county's population for basically how many of them had a positive COVID-19 case. Okay, so that's this axis here. Then on the x-axis, we have the percentage of the population that's fully vaccinated for that most recent date that we have. So you can see some counties, they are vaccinating quite a lot of people compared to other counties. And they don't have as many COVID-19 cases since February 1st. Then up here you can see counties that are getting vaccinated a lot, but they still have had a lot of COVID-19 cases. These dashed lines, they're the average, by the way. Maybe I should make a label for that too. There are some things I should update. I made a lot of these over the past, 2 days. So these dashed lines, basically it's the average for the percentage of population fully vaccinated for all of the counties. And then the average amount of COVID-19 cases per million for all of the counties. So Mono, I think that's a really small county. Alpine, that's really small. But you can see like LA, they have more than 25% that's fully vaccinated now, but they still have a lot of cases per million. Also, if we didn't scale this, so this is using that equation that I talked about in that email. If we didn't scale this per million, you would see all of these counties at like the very bottom here, and then LA is like way up top, just because their population is so much larger than everyone else. Again, and here we have people that they're not really getting vaccinated and they have a ton of cases. Again, most of them are like small counties, but you have like San Bernardino and you have like Riverside as well. Then down here we have not a lot of them are getting vaccinated, and there's not that many cases though. So for this is also the case of small towns. So I'm thinking that they're small towns that aren't densely populated or something like that. I was going to also have you basically show the population for each county. And if you want, you can do that too, and like on the side with the legend, but I decided in the end to not do that. Alright, so that's all the figures for this project. And let's see if there's anything else important. The grading breakdown, that's basically all the same. The only thing I added here was were array size, or were they pre-allocated. So you need to do that.
What happens if we don't? How much will we lose?
I mean, probably only a few points, but it's so easy to do them and it's going to make your code more efficient, so you should do
Oh, it does? Alright.
Yeah. Okay, plot format requirements. It's a little different than last deliverables just because we have different figures that we're making here. You always bring in McDonald's, don't you? No, there's no plot for that.
My dream job.
Okay, so same thing as last time. There shouldn't be any exponents present on any of the axes. The figure title should be descriptive without being too long, and you should have the relevant date in the title. So I think this time I actually do show the date in all of the plots. Oh yeah, and then for the heat maps, the x-axis, so this is when I say it, it should be shown in a month, day format, so you can change the format of your date time value that you have in MATLAB. And the interval that we have is, it's not day by day, it's week by week. Okay, so for the reference pictures, you just saw all of them, but I also gave you all of the pictures in the deliverables this time, just because they're a little more tricky than last time. Okay, so you can see all of them here. And then the example write-up, I'm going to make one. I'll post it hopefully sometime today, but I'm going to do an example write-up that's a little more in-depth. Basically, I'll do like an example write-up for an entire script that we've made in class. And you can see what that'll look like. Alright, so any questions on Project 2 before we continue where we left off last time?
I have a quick question about Project 1. Are you going to post the answer sheet for how to figure it out?
For like the code?
Yeah.
Yeah, so I'll do that. There's a few students that have special circumstances where their project was extended a bit. So once everyone turns it in, then I'll actually go over the code. Hopefully in class if we have time, but maybe I'll just make a video going over it.
Okay, thank you.
Yeah. Alright, anything else? Alright, so again, the deliverables that are up on Canvas now, and all of the data sheets are up too. So if you want to get started like today, you could do that. And you know, I'd really, of course, recommend to get started as soon as you can, because it's gonna probably take longer than the first project. Oh, should open up actually MATLAB, not in here. Nested loops, you might use them. I did for myself. It depends on how you write your code. So I think for one of my sections, I used a nested for loop. And we're going to have 2 examples on a nested for loop today, though. Oh man, my webcam froze again. That's great. Okay, so this is the other code that we're going to make today. Let me go back here. Did I have it here? Yeah. Alright, so we're gonna finish off on that baseball example that we were doing last class when I had a brain fart. I'm gonna blame my lack of sleep. That's easier. Uh-oh, there's my code for Project 2. You can only see the very beginning when I read the table.
table.
Oh, you're so close to looking at it all.
Scroll down a little.
There you go.
So you record this, you post it on YouTube, I could download and slow it down.
You could. It would probably still be too blurry, though.
Yeah.
Okay. Oh, now I'm had a Freudian, what is it, slip there? I was going into my Project 2 code again, because we're talking about it. Okay, let's go here.
Thanks for telling us how to further distract you and
Okay, let's open this up. Alright, let me run this. Alright, so we're going to be making these plots. We're going to make 8, but currently I just have them showing 3 of them. So let's pick up, we'll have a little review on what we did last time, and then I'll explain my brain fart from last time. So we read our table, then we did some conversions here. Here we initialized our arrays, or we pre-allocated the size of the arrays that we were making. In this case, I was making empty cell arrays. So to make an empty cell array, use the cell command. To block out a massive amount of code, you can do a %, and then a curly bracket, and then go down here to when you want to end it. There you go. So an empty cell array, that's just going to be an empty cell array. So it's empty. Okay, so the first thing we did was we found the indices for our players. So we have 6 players here. I'll open this up here. So we have all of these 6 players, and we wanted to find their indices. So to do that, we made a new cell array called player IND, and let's run this again. Let me change that visibility. Okay, so let's take a look at those indices. We already made sure that that was correct last time. Oh, you can see my nice variable name. It took me forever to get the legends to work properly. I'll talk about that once we get to that, but it was such a pain in the ass. Okay, so we have this cell array here for the indices for all of our 6 players. So they show up a different amount of times in our spreadsheet. So if we want to get all of the indices, and if we want to do it like easily, we can just use the cell array, because we can have arrays at different lengths if we have a cell array. Okay, let's take our first player here, and let's check. So we have Shane Bieber. Let's go to a random row here, 1977, so he should show up in our table on row 1977. If he doesn't again right now, I'm going to be even more embarrassed than last time. 1977, there he is right there. There's Bieber. Also, it's kind of ironic because last time, even before the class, the night before, I actually did some testing to make sure that everything was correct down here and in a kind of a different way, and I did multiple checks and it was correct, so I should have remembered that. Okay, so that's our player indices. They're good, and where we left off last time was looking at the indices for the pitch velocity. So we found indices here called pitch velo. So we have our 6 players still, and currently I'm looking at 3 different pitch types. So let's go to pitch name. Pitch name is right here. So we have these 3 different pitch types. So what this is we have our 6 players and then our 3 different pitch types. So column 1 here is for all of our 6 players for the pitch type of a 4-seam fastball. Column 2 is for all of our players for a changeup, and then column 3 is for all of our players for a curveball. So if you see these empty cell arrays here, that means that that player never threw that type of pitch. So I think last time, what was it? I think we were still looking at, I forget exactly what we were looking at when it went to shit. I don't know. So let's just choose a random one. Let's go to column 3 here, and let's do player 4. Oh, that's Kershaw, huh? Okay, so that's for Clayton Kershaw. He's our 4th player. And we're looking at a 3rd pitch type, which is a curveball. So let's check for that when this shows up in our table. I need to... I'm not looking at the right thing here. Take this out. So pitch. Oh, pitch name ID. I meant to look at that. Okay, so again, so we're going to look here. So we're going to look at Clayton Kershaw. He's our 4th player. And then for the 3rd pitch type, that's a curveball. So let's open this up. So if I go to a random row here, this doesn't mean that it's row 159 in our table. How we have our code here, it means that it's row 159 for the player index for Clayton Kershaw. So let's, didn't want to open, oh, I hit it, that's why. So let's look at our code again. Okay, so for pitch name IND, what we're doing is we're finding the index for that specific pitch type for each player. So we're using the indices that we already found for each player, And now we're finding the index using those indices for when they threw some specific type of pitch. So this is something that you maybe want to take a look at in a little more depth, because it's like we have like layered indices that we're finding. Let's go back over here. So again, let's choose a random row here. So we're looking at the pitch name indices. So 159, that means that we need to go to pitch our player indices, and we're going to do this for Clayton Kershaw. And that means for this pitch that this is row 159 for his actual player indices. So let's go to row 159 here, 159. And now this means that this is row 775 in our table. So basically row 775 in our table, that should be for Clayton Kershaw throwing a curveball. So let's make sure. So let's open up our table. I already forget what I said. What row did I just say? 775. So 775. Here we go. There's Clayton Kershaw. Right there. 775 right here. And CU, that stands for curveball. But let's go to the specific row. I forget what it was, like 79. Yeah, 79. And there it is. There's a curveball. So that's good. Let's do one more though. Let's make sure. Even though, I mean, I checked before, but we'll do it again. So let's do it for, let's say, column 2 here. Let's do it for our last player. So our last player is Jacob deGrom. And this pitch corresponded to a changeup. So let's go to, I don't know, 271. So this means that for Jacob deGrom throwing a changeup, this index right here, that stands for the index for his specific indices. So let's go to player IND. So we got Jacob deGrom, all of his indices. And let's go to row 271 for him. 271. Right here. So that means on row 1298 in our table that we should see Jacob deGrom throwing a changeup. So 1298. Okay, here we are. There's a changeup. Now let's make sure it's Jacob deGrom. And here we go, Jacob deGrom. And he threw his changeup at 91.6 miles per hour because he's insane. Alright, so our indices are good. So now we can basically make our plot. So let's go over this because I want to go over the heat map and the scatter plot as well today. And that example also uses a nested for loop too. Okay, so we have all of our indices, and then here I'm using those indices to then calculate the velocity for each pitch type. So I made our cell array here, which we already pre-allocated the size for. And we're going to be looking at t.release speed in our main table. That's the column, so that's going to be how fast a player threw the ball. We're going to use their indices in general for whenever they show up in the table. And then we're using our kind of layered indices for the pitch name. So that means that we're using indices for each specific pitch type for each player. Okay, so if I look at this cell array here, this is what we have. So this means, like for what we were just looking at, here, this means we have all of the velocities for Jacob deGrom throwing a curveball. And then for another column here, this would be like right here. This would be for player 3. Who was that? That was Lucas Giolito. That would be all of his velocities for throwing a changeup. Okay, so we do that, and then we also do this for pitch spin, so that's how many revolutions per minute that a ball is thrown. And that's going to look the same as our cell array for the velocity. This is going to represent the spin for each pitch. Okay, And then we're going to make our plot. So what I specified here is figure of j. So we're still inside of our loop here. So when I loop once, we're going to make all of the plots, or we're going to make a scatter plot for a forcing fastball. That was our first pitch type. You see it's figure of j, so j is looping through the pitch name. So our first pitch name, that was a forcing fastball. And let's look at the length of pitch name. So that's up here. I basically made another line to say how many different pitch names that I want to include in the graph. So currently, I'm just going to show 3, but there's up to 8. Okay, so figure of j, again, that's as we continue to loop, that'll make a scatter plot each time for each